Hey everybody, it's your favorite chemistry teacher here. In this video, we're going to talk about classification of matter. We've talked about different things about matter. We've talked about properties and characteristics and changes and states, and now we're going to include in here classification of matter. Okay, so let's move on here. Maybe I'm just drawing over here. Here we go. So I want you to pause the video here and draw this flow chart into your notes. Alright, so everything is made up of matter, and matter can be divided into two different things, two different categories. We can have mixtures and we can have pure substances. Alright, we're going to talk about each one of these, mixtures and pure substances, and then we're going to talk about each different type of mixture and each different type of pure substance. Alright, but everything in the universe can be described as matter. We just need to be able to figure out which category it can go into. Okay, so let's start with mixtures. The first type of mixture is a homogeneous mixture, and the definition for a homogeneous mixture is that it is the same throughout. And the really easy way to remember this is by your prefix. The prefix homo means same. Okay, so homogeneous mixture looks to your eyes, when you look at it, it looks the same. Alright, so you can't tell that there's more than one thing in this mixture. We call homogeneous mixtures solutions. Alright, that's a term that in the chemistry world you should get familiar with. Solutions are homogeneous mixtures. It's basically a solid that has been dissolved into a liquid. Usually that liquid is water, but not all the time. But anyways, there's a solid that's dissolved into a liquid, and that is a solution. Okay. Here's a couple of examples of homogeneous mixtures, and I'll give you another one here in just a second. The other type of mixture is heterogeneous, and again, another easy way to remember heterogeneous is by your prefix. Hetero means different. Okay, so heterogeneous, these types of mixtures are clearly made up of different things. Okay, with your eyes, when you look at it, you can see different things in this mixture, and you can tell, oh, that's this part and that's this part. There's two separate parts, or three or four or five separate things in this mixture. It doesn't look the same. Okay, so it looks different. That's a heterogeneous mixture. So you could see bubbles or chunks or flakes or something different within. If you think to our day one demos, and if I was in class I would get this out and show you again, but the little pop bottle with oil and blue water in the bottom, there is two separate things, visibly different things in that substance or in that sample. So that oil plus water is a heterogeneous mixture because we can visibly tell the different portions of that mixture. Okay, here's some other examples. Dirt, obviously, you got small rocks, different types of dirt, things like that. Blood, that's a good one, with the solid blood cells versus the liquid plasma of the blood. And so if you were to let it settle, and I know it's kind of gross, but if you took a sample of blood and were to let it settle, the blood cells and the platelets and the solid portions of that solution, or that mixture, it's not a solution, of the mixture, would settle out and fall to the bottom, and then you would be left with a liquid up at the top, and you could visibly see different portions. Okay. A couple of examples that I didn't put on here, and I want you guys to kind of in your head, before I tell you where they go. I want you to put them into one of these two categories, homogeneous or heterogeneous. And the first one is salt water. Okay, think about where that one goes, hetero or homogeneous. And the next one is pond water. Where does it go, homogeneous or heterogeneous? Okay, and if we think about this, we should think about, do these look the same all the way through? If I were to take a scoop of salt water and a scoop of pond water and set them on the table in a beaker, what's going to happen? Is this salt water going to settle out, or is it going to stay looking the same? It's going to look the same. And so salt water is a homogeneous mixture. Pond water, on the other hand, has a whole bunch of stuff and gunk and junk floating around in it. So if you took a scoop of pond water and let it sit on the table, all that gunk and junk and stuff is going to fall and settle out to the bottom, and then we're going to be able to see different things within there. All right, so pond water would be considered a heterogeneous mixture. Okay, those are very important. It's going to be necessary for you to be able to tell the difference between homogeneous and heterogeneous mixtures. Now let's talk on the other side of that flowchart, pure substances. In an element, and the elements were was the first subsection of pure substances, if you look back at that flowchart that you wrote down at the beginning. So elements, in a sample of an element, every atom is identical. Okay, every atom in the sample is identical. It's the same type of atom. Okay, that means if we were looking at it on the periodic table, everything in that sample would have the same symbol, whether it's H for hydrogen, or O for oxygen, or N for nitrogen, or throw in any of them. But as soon as you get to something like carbon dioxide, where you have carbon and O, that's no longer an element. Okay, that would be the next type. So there's your individual element symbols. Compounds, this is when we could, and I'm going to write this in here, we could have more than one type of atom. So this could be more than one type of atom. It doesn't have to be, but it could be. And the kicker, though, that makes this still a pure substance is that every molecule is the same. So I'll put, I think it's, yeah, this is what I want to get to. So this little image here, I can also probably argue that this would also be a compound. It is still an element, but it's a compound because we've got atoms bonded together right here at that bonding point. Okay. Now, what's important here is that in elements, all of these, let's just say that these are helium atoms. Okay, and all of these atoms in this sample are helium, and there's nothing else. It is pure. They're only made up of one single element. Everything has the same symbol. Okay, and so this would be considered an element in the type of pure substance that it is. Over here, we can, if we're calling this oxygen, everything still has the same symbol. Okay, all of those are O's on the periodic table. And because of that, it's considered an element. Because there's more than one bonded to each other, it's considered a compound. So this can be both. All right, but it is still a pure substance because there's nothing extra within that. It's just oxygen. Okay? Now, before we move on over here to the water, if I were to take both of these samples of helium and oxygen and put them in the same container, do I still have a pure substance? No. The answer is no, because within this sample, now I have helium and oxygen, and not every atom is the same anymore. I've thrown in other things. And so if I were to put helium and oxygen into the same container, and these guys are all together now, this is no longer a pure substance. It would be a mixture. Okay. Now let's look at compounds over here again. So here we've got, this would be H and O for H2O. Okay. Again, we've got chemical bonds going on here. So this is one particular substance. It's a compound of, it's a molecule of water. And in this sample here, I've got a whole bunch of water molecules. Since every molecule is the same, it is considered a compound. Okay? There's nothing extra. As soon as I throw in some salt in here, or maybe some sugar, then it is no longer a pure substance anymore. Okay, but as long as it's pure H2O, now we have a pure substance, and it's not an element because I can't find water on the periodic table. I can't go up to the periodic table on my wall in the classroom, or on a periodic table that you search up on Google. If you do that, you don't find water. Okay? You don't find H2O together. You find H and you find O, and they're separated. So that tells you that it's not an element. It's got to be a compound. All right? That, I believe, yes, that is it for today's video. On the worksheet, make sure you chime in and ask any questions if you have them. I do want you to stay on the Zoom call while you finish and work on that assignment, please. All right, make sure that you come find me and ask questions if you have them. Good luck.